Welcome. This is adding integers, part 2. So in this number routine, I would like you to copy this number line, and you're going to complete it on your whiteboard. So, as you can tell, -5 is to the left of 0 because it is negative. 7. Where would you put the number 7 on this number line? I would put 7 on right of 0, somewhere right here. Where will you put -4 on this number line? To the left or to the right? To the right. Put right there. So -4, I would put right there. So remember, negative goes backward. Think of it: 0, -1, -2, -3, -4, -5. Next one. Integer greater than -2. Integer that is greater than -2. Well, here is -2. So there's only one other integer that is greater than -2, -1. Again, a number line goes from least to greatest, from least to greatest. So some people say, oh, -3, -4, -5, -6. No, those are numbers that are less than -2. -1 is the only negative number that is greater than -2. Name an integer less than -5. I'll say -8. Where would you put the absolute value of -6? That means how far is it from, oh, let me pinpoint. So we did 7, we did -1, we did -4, -5, and -8. So how far is it from 0 to -6? What is the distance? How many units away from 0 to -6? -1, -2, -3, -4, -5, -6. That's 6 units away. So that really is equal to 6. And our last one, a rational number. Think of any rational number. It's a number that can be written in fraction form. Can 5 be written as a fraction? Yeah, 5/1. I'm gonna or can a decimal like 2 3/10, like this? 2 3/10. Can that be written as a fraction form? Yes, it can. So I'll use that one. 2 3/10. And that is our number line. There's no there are multiple ways of doing this. So your may be different from mine. So this is a thermometer. So the thermometer is currently 8 degrees. Where would you put this arrow if the thermometer is currently 8 degrees? Let's see. Here is 0. As you can tell, this is 0. It goes above 0, positive. Below 0 is negative. So it is, the scale is counting by twos, I believe. 2, 4, 6, 8, 10. So if it's currently 8 degrees, 2, 4, 6, 8, it goes right here. It dropped 12 degrees. So if it's currently 8 and it dropped 12, 2, 4, 6, 8, 10, 12. Now it is at -4. It rose 2 degrees. So it goes up 2 degrees. So it goes right here. -2. It drops 6 degrees. 2, 4, 6. So it goes right here. What is, so that is that's at -8. What is the difference between the low and the high? So this is at 8 degrees, and this is -8 degrees. What is the difference? Well, let's see. Let's count. Starting at 8, 2, 4, 6, 8, 10, 12, 14, 16 degrees. 16 degrees. There is a difference of 16 degrees from the low and the high. So model the integer using model the integer 2 using algebra tell. So how would you model 2 using algebra tell? Model the integer 2 using 4 algebra tells. That's positive 4. So that's not 2. I have to use 4 algebra tells to model 2. If I put this one, this 0 pairs out, so it's equal to 1. If I put this here, these two make 0 pair to cancel out, and I'm left with 2. Oh, I'm done. So I modeled it. I modeled the integer 2 using 4 algebra tells, and these are the 4 algebra tells I used. So this is to see if you still remember what 0 pairs are. Model the integer -3 using algebra tells. Can you model the integer -3 using more than 6 algebra tells? So here's -3. How can I keep it as -3? How can I put more algebra tell without changing the value of this -3? 0 pairs, 0 pairs, 0 pairs, and more 0 pairs. Let's see how many tiles I use. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I use 11 algebra tiles, so I fit the conditions. I did model -3 using more than 6 algebra tiles. So, number 1, 3 plus 5. How would you draw that? 1, 2, 3. I'm adding 5 positives to it. And that value is 8. So it's 3 plus 5. All right, so I start at 0. 3 means I need to go 3 units to the right. And what is plus 5? 5 means I need to go 5 more units to the right. So what number did I stop at eventually? 8. That's why it's 8. Number 2. Now let's get to a little harder. So let's model this. -4. I'm going to add one more negative to this picture. Do you see any 0 pairs here? No, I don't. I see the value of this expression as -5. How would I show this on a number line? So I start at 0. The first number is -4. Negatives go to the left, 4 units to the left. The second number, I'm going to add another error to this. I'm going to add -1 to this. That is 1 unit to the left. So I stopped at -5. Number 3, 5 plus -2. So I have 5. I'm going to add -2. What happens to these? These become 0 pairs. So I'm left with 3. So 5 added to 2 negatives cancel out 2 0 pairs. You're left with 3. How will I write this one using a number line? So I start at 0. I go to 5. -2 means I go back to, stop at 3. Number 4, -4. I'm going to add 3 positives to this. Whoops. What do you call these? 0 pairs. You're left with -1. A value of this expression is -1. So again, starting at 0. -4 means it goes 4 units to the left. Add 3. That's 3 units to the left or right? To the right. And I did stop at -1 to check my work. Number 5, -4 plus 3. Add 4. 4 is positive. These make 0 pairs. I'm left with 3. All right, let's do a shortcut. what do you get when you have four negatives and you add four positives? Think about it. Four negatives with four positive, they all zero paired. That's why 3 is what's left over. How would you model these three integers using a number line? I start at 0. -4 means I go 4 units to the left. The second number is +3. That's 3 units to the right. The third number is +4. That's 4 units to the right. 1, 2, 3, 4. And it stopped at 3. Number 6, 2 plus 3 plus -3. So 2 plus 3 is 5. I add 3 negatives to this. These become 0 pairs. I'm left with 2. Here's another hint of advice. If I add 3 plus -3, won't those cancel out, become 0 pair, and I'm left with 2? So starting at 0, 2 is 2 units to the right, plus 3, 3 units to the right. That stops at 5. And then -3. I mean, I go back left, 1, 2, 3, left 2 units, left 3 units, and I stopped at 2. Number 7, yeah, there you go. So in this one, you will try this. So looking at this number line, can you turn this number line using integers? So if I start at 0, it goes left 1 unit. That's -1. It goes left 1, 2, 3 units. So that's -3. And it stops at -4. Next one, starting at 0, it goes right for 5 units. That's +5. It goes left 2 units. That's -2. And it stops at 3. And the third one, it goes left 4 units, -4. It goes right 1, 2, 3, 4 units, +4. And it stops at 0. Our last activity is you are going to be getting playing cards, and you're going to be drawing some playing cards. So for example, if you draw a black card, it will represent positive. If you draw a red card, it will represent negative. If you add them together, what do you get? So for example, someone drew a black 3 of club, and someone drew a 5 of hearts, which is -5. So let's draw this. 3 positives, 5 negatives. These cancel out, and you are left with -2. Again, if you need to use a number line, 3 units to the right, back 5, and where did we stop at? -2. And what about this one? Someone drew a red diamond, which is 7, which was negative. Someone drew a heart of 2, so that's -2. So 7 negatives, 1, 2, 3, 4, 5, 6, 7, plus 2 more, that's -9. Let's use a number line starting at 0. Go 7 units to the left, 2 units to the left, you stop at -9. So the player with the higher sum wins. Using the equality, less than, greater than, or equal, fill in the blank. So who won here? Someone who has -2 or -9. Let's think about it. -2 is right here. And the number line goes from least to greater, so it's greater. So player A has greater points than player B, so player A won. And this is study of adding integers.